Okay, so in this video, we're going to take a look again here at the Python code for Black Scholes Monte Carlo, and we're going to set up in Spyder. So using the Anaconda navigator, we're going to re-estimate this Black Scholes Monte Carlo code. So we go into, just a note here, we go into the Anaconda navigator and we launch Spyder. That normally takes a second, so I might just pause. Okay, and it is launched, and then we go into Spyder Python 3.7 file, new file, and we can paste our code in here. And then we have 10,000 runs here. So let's just execute. Now, while that's happening, it'll want us to save. Okay, we'll save. We get a value of 1045 for the call. So there's a call price and a put price at 552. Now we should be, 1045 is quite close. And we're looking for 557 for the true value. Given the parameters that we've specified here, we are looking for 1045 and 557. So we might re-estimate again, noting that okay, so let's run again, and we'll increase the number of steps up to 100,000. And we've got 1049 and 561. So let's go to 1 million. We've go to 1 million, run again, and it's going to take a little bit of time here. Now we're 1046, 558, and let's go 5 million estimations, 5 million, run, and this might take a little bit of time. And is it worth pausing? Might pause, and less than probably a full minute, these values now are very close to the European values of 1045 and 557 using Monte Carlo. So I seem to have to go to about 5 million steps here to reach a two-digit level of 2 decimal places level of accuracy.